Ivan makes both you and your child happy for life. Ivan is to win. Give your child the Ivan advantage now.
In classes. In this class, I am going to explain one of the most important previously asked JEE question from the chapter Laws of Motion. And the question here is this one. As shown in figure, a block of mass 10 kg. The block mass is 10 kg, which is lying on a horizontal surface, which is pulled by a force of F at an angle 30 degrees with the horizontal. With the horizontal, the F makes an angle 30 degrees. The quotient of static friction value is given as 0.25. The block will just start to move for the value of capital F. That means we are going to calculate the capital F value here. For what value of F? The block just start to move. So here given that G value, acceleration due to gravity, is given as 10 meter per second square. And the options are given as, first option is 20 Newton, second one is 33.3 Newton, third one is 25.2 Newton, and the fourth one is 35.7 Newton. This question was appeared in 1st February 2023 JEE Mains in Shift 2. Now go for solution. Here, before going into the problem, what are the data which is provided in the problem? So the data given in the problem, let's say mass is given as 10 kg. It's is on the horizontal surface. The force F makes an angle 30 degrees. Quotient of friction, and the next one is G, acceleration due to gravity. So this data provided in the problem. So given that mass is 10 kg and quotient of static friction is 0.25 and theta, angle made by the force with the horizontal 30 degrees, and the G value is given as 10 meter per second square, right? Now here, before going to solve the problem, this problem based on what concept? Here, equilibrium concept and free body diagram. So these two we use to solve this problem. So first, I'm going to draw a free body diagram for this block. The mass of the block is 10 kg, means it has its weight. Its mass is 10 kg. Weight is acting vertically downwards, always toward the center of the earth, right? So that means weight is acting along this direction. What is it? Mg. Mg is the weight. And here there is a contact between the horizontal surface and the block. That means there is one more force called contact force, normal reaction, which will also act on this body, which is always act opposite to the surfaces which are in contact. So surfaces are in contact is this portion. Here onwards, along this direction, perpendicular to the surfaces are in contact, the normal reaction is acting. N. One more here is force F. This F makes an angle 30 degrees with the horizontal. That's why we resolve this F into two rectangular components. So its horizontal component comes along this direction, which is F cos theta. Actually, theta is the angle made by the force with the horizontal, then F cos theta is the horizontal component, right? So that means here F cos, what is that angle here? 30 degrees. That comes along this direction. One more is its vertical component. The vertical component of F, which will act along this direction. What is its value? F sine 30. This is the vertical component. So horizontal component, vertical component. We resolve F into two components. And here main important force is frictional force. The frictional force will act along this direction, always opposite to the tendency of motion. Normal to the contact surface, normal reaction is acting. And frictional force is a small f, which is always act opposite to the tendency of motion, right? That means it has a tendency to move along this direction. That's why frictional force act along this direction. What is formula for frictional force? In terms of normal reaction, F is equal to mu into N, where mu is the quotient of friction. Now, this block just ready to start. So, tendency of motion. That means along the horizontal direction, the net acceleration is 0. Just it is ready. That means whatever the force which is acting along this direction is balances with the net force which is acting along this direction horizontally in the opposite direction. Similarly, we apply same equilibrium condition for the vertical direction also. So here, first of all, we apply it for horizontal direction. What is the force which is act along this direction? That is F cos 30, which is balanced with frictional force small f. So F cos 30 is equal to small f. And the next one is here along the vertical direction. Observe here, along the vertical direction, what happens? Upward, total two forces are acting, right? What are the two forces? One is normal reaction, second one is F sin theta. These two are acting vertically upward, right? Vertically upward, these two are acting. That means upward acting forces sum N plus F sin 30, which is equal to downward acting force. Downward is acting force is what here? Weight of the body, which is equal to mg. So this is the application of equilibrium condition for the vertical direction. So this equation is nothing but this one, right? So this we applied equilibrium condition on the vertical direction, as well as this we find by using equilibrium condition on horizontal direction. Here onwards, what is n? Here onwards, n is what? Bring this f sin 30 to that side, then n equal to mg minus f sin 30, right? So this is the n value. Now, what is frictional force? F equal to mu n, right? So F equal to small f, frictional force equal to mu into n. What is n? You substitute this one. Then mu into n is what? mg minus f sin 30. This one, right? So here the next step is what? Here onwards I am going to write n value. What is n here? Bring this f sin 30 to this side, then it becomes mg minus f sin 30. Next, now this is the complete free body diagram of the given block. And here f cos 30 is equal to mu s into n along the horizontal direction equilibrium condition. Similarly, along the vertical direction equilibrium condition we applied, we get f sin theta plus n equal to, already in the last slide it is there, f sin 30 plus n equal to mg. From here we have taken n as mg minus f sin 30, right? So this one. So here whatever the n value is there, this one, mg minus f sin 30, substitute in this n normal reaction, right? Then f cos 30 is equal to mu s into, instead of n I am writing mg minus f sin 30. Now further simplification, what happens here? F, here I am writing f cos 30 is equal to mu s into mg minus this mu s multiplied inside. What I'm trying to do, mu s is multiplied inside, minus mu s f sin 30, this one. Bring this mu s into f sin 30 to this side. Then what happens here? If we bring this mu s into f sin 30 this side, mu s into mg, which is equivalent to, already f cos 30 is there. Here onwards, minus mu s into f sin 30 comes to this side, becomes as plus, which is equal to mu s f sin 30, right? This one. So here onwards, I'll get common f. Then mu s into mg is equal to, after getting f common, what left inside? Here cos 30 is there, plus mu s into sin 30. Here onwards, I am going to write the formula for f. To write formula for f, whatever this value is there, I bring this to this side. Then what is formula to find capital F? Which is equal to mu s into mg by, what is here? Cos 30 plus mu s into sin 30. I'll write here that one. Cos 30 plus mu s into sin 30. So this is the formula which we are going to use to solve this problem. So here, observe here, just multiplication of mu s inside. Then you'll get this step. F cos 30 equal to mu s into mg minus mu s f sin 30, right? Next, bring this mu s f sin 30. These steps only here text form are there. So here, after that, this is the shortcut formula, right? So what is F formula? The force required to just move the body. That is F equal to mu s mg by cos 30 plus mu s sin 30. So in this formula, so this is the formula. Now I'm just erasing the pen part. So this is the formula, right? In this formula, now I'm going to substitute the data. What is the data? Mu s is 0.25, m 10 kg is given, g 10 is given, cos 30 we know, sin 30 we know. Those values substitute here. This one, mu s 0.25 into mass 10 kg into g 10 meter per second square by cos 30 root 3 by 2 plus mu s 0.25 into sin 30 1 by 2, right? So what is next step? Further simplification only. This one is the further simplification. So 0.25 means 1 by 4 into 10 into 10 by root 3 by 2 plus 0.25. How I am taking? 1 by 4 into 1 by 2. Then the next one is this one in further simplification. So here some part is going to be cancelled. After that you are getting the answer as this one. F equal to 25.2 Newton. So the force required to just move the body is 25.2 Newton. Thank you.